Did you know that with strain measurements, the measurement signal needs to cope with two nonlinearities? They are very small and can be neglected in the normally occurring elastic range. These nonlinearities need to be taken into account, however, with extremely high strains. HBM's measuring amplifiers indirectly do so by using a practical effect. The first nonlinearity is caused by the Wheatstone bridge circuit. With a given change in strain gauge resistance, the true voltage signal is smaller than assumed in the approximation formula. The gauge factor's dependence on strain results in a second nonlinearity. With a given strain, the change in resistance is greater than to be expected with a constant gauge factor. The nonlinearities have opposite effects and thus virtually cancel each other out. The following test shows that the modular MGCplus amplifier utilizes this effect to measure correctly both in the range of small strains and with high strains. The ML801B amplifier and the AP814BI connection board are used as plug-in boards. Two strain gauges installed on a bending beam supply the input signal. The first strain gauge has a common resistance value of 350 ohms, and the second one a resistance of 347 ohms, representing a high pre-strain of approximately minus 18,000 micrometers per meter. At first, the initial values of both strain gauges are recorded, and a mechanical strain of approximately 1,000 micrometers per meter is applied to the bending beam. As expected, the measurement system measures this strain in a uniform way. The next step is to set the initial values to 0, when once again applying a strain of approximately 1,000 micrometers per meter, both channels display almost the same measured value. The mutual compensation of nonlinearities, therefore, gives excellent results in both cases. Every measurement chain should ideally be calibrated. With a complete measuring chain using, for example, force transducers, traceable calibration is possible, while with a complete measuring chain using single strain gauges, this cannot be done, since it is impossible to apply traceable strains. When calibration units are used, however, there may be apparent deviations of the test result, in particular when the calibration unit ignores the nonlinearity of the gauge factor. When simulating strain in the high strain range, the fact that the gauge factor lacks nonlinearity becomes noticeable. The nonlinearity of the Wheatstone bridge results in a smaller voltage signal, while there is no increase of the difference in resistance due to nonlinearity of the gauge factor. As a result, the measured value at the amplifier appears to be too small. In this case, we recommend using a correction formula when working with the MGCplus. This formula can be downloaded from our website.